Good morning to everyone and welcome to the FAIRWork webinar. I am Rishank Chevari from IOTNE, and this webinar is a part of a dissemination activity where we have series of webinars, and this is the fourth webinar in there. In this webinar, I am going to present to you about the initial high-level architecture of the FAIRWork project, and then more emphasis is given on implementation of DAI-DSS knowledge base. Next, I would like to take you to the next 30 minutes. What we would like to present is, first, I would like to present about the FAIRWork project idea. Then I would like to introduce you about the use cases. Then I would like to present you about the key building blocks of our high-level architecture, and then map with the use cases with these key building blocks. Then furthermore, I would like to just give you a brief overview about each key building block of the architecture. And then again, we would like to focus on implementation of the knowledge base. The knowledge base in this project is implemented by the IOTNE. IOTNE is expert in the development of standard-based software products for product data exchange, product lifecycle management, and long-term data archival and retrieval. So majorly our IOTNE products are implemented based upon Express Data Manager, which uses ISO step standard of 10303, and all our we majorly work with research and development projects with European Space Agency, Airbus, and Lockheed Martin. Similarly, we also work with EU projects like FAIRWork project, and our main expertise is on data management and data sharing solutions. I would like to just present you about our FAIRWork project idea, which will develop and context for the next coming slides. So the main goal of the FAIRWork project is to support complex decision-making processes in industrial environment with AI technologies. In our case, these will be manufacturing companies which involve multiple stakeholders like machines and humans. So what we would like to do is to support the human decision maker who need to make decisions during a design time of the decision-making process or execution of the processes. So here we would like to use some AI technologies which will help the decision maker, and the provided decisions will be fair and democratized by considering all the involved relevant stakeholders like the persons, vehicles, and robots. Now we have the FAIRWork project idea. I would like to just take you to introduce the real world use case scenarios where we can use our this DAI-DSS architecture and provide decision support to the real world use case scenarios. Here we have two manufacturing companies. First is Flex. Flex want to optimize their programming of manufacturing robots for low volume production, and CRFS is a car manufacturer who want to optimize their throughput between the succeeding production lines. So based on the design thinking and business processing modeling, we have further identified the key areas in these both manufacturing companies where we can potentially use our AI decision-making services that can help the human decision maker. In case of Flex, we identified automated test building, worker allocation, and machine maintenance after breakdown are few scenarios where we can potentially use our decision support tools to help the decision maker to make decisions. Similarly, in CRF, we would like to use our tool for optimizing worker allocation, delay of materials, and quality issues. As you can see, in both our manufacturing environments, still we are trying to use our tool in different scenarios and provide decision support to the user. Now we have our FAIRWork project idea and the use cases where we can potentially use this DAI-DSS for providing decision support. I would like to just introduce about the high-level architecture with the key building blocks. Here is the overall high-level architecture of the FAIRWork project. Just don't bother about the minute details in the picture. Just concentrate on the overall high-level building blocks. First, we have this real-world use cases in the production. What does this mean? As I introduced earlier, we have decided 6 use case scenarios for our project, and these will be these use case scenarios where we have complex machines, humans, and robots working in a real-world environment. What would we like to do here is we would like to get the production plan data or simulation data or sensor data from the robots or the machines, and we will also introduce some human aspect in these decision-making scenarios. So we are introducing an intelligent sensor box which will collect some biosensor data and also working environment conditions. So what we do here is we will collect all this relevant data which can be used to support the use cases for decision support, and this data is collected and stored in the knowledge base. What does this knowledge base does? It is acts as a central knowledge repository in our entire FAIRWork architecture. Each other component in this architecture will use knowledge base as a single source of truth for the accessing the data, and it will use this data for further model training. Like AI can use it for AI model training and deployment, and user interface pull the data from the knowledge base to display some key metrics or values. Then we have the configurator framework. What does this configuration framework is used to create decision models, and it can also configure the AI models with relevant data. Let's say we have an AI service which need some data from the knowledge base. This configuration framework can map this data source to the respective AI services. Similarly, the configuration framework can also use it to configure the user interface dashboard for displaying some key metrics, just like if you want to display some sensor data from the knowledge base of a particular machine, you can configure that from using the configuration framework. Then we have the DAI-DSS AI enrichment services. This is the place we will have the list of AI services which we want to implement and use to support the decision-making scenarios. Then we have orchestrator, which is an central component in our framework, which will ensure smooth communication between each other component like configuration, knowledge base, enrichment. It will ensure there is smooth interaction between components, and the user request or the request from the user interface is first opened by the orchestrator, and the orchestrator decides whether it should invoke a particular AI service, or it need to do some simulations using multi-agent system, or it need some other help from configuration for a modeling and decision process scenario. Finally, we have our user interface. This is the place where user can interact with our framework for decision support and for getting results displayed. Now we have key building blocks of our architecture. Let's see how these blocks will come together to solve a particular use case scenario in our use cases. Here I am showing you the mapping of high-level architecture with the use cases of Flex and CRF. As I said earlier, we have used design thinking and business process modeling for each scenario. And what we have done is we have identified and abstracted few use case challenges, which is to find similar projects, find relevant experts, and simulate production process or find similar problems. What does this does? This will enable the AI services. Let's say we have implemented some AI services which can find similar projects, or the AI services can find similar problems, or it can it can be used to simulate some production process. By this use abstract challenges, what we can do is we can support not only the use case challenges which we have presented in this project, but also any use case which are relevant in other manufacturing environments. So here you can see the DAI-DSS AI enrichment. It will have the list of AI service catalog. That means we will have some list of AI services which are implemented. Let us consider an example here. In Flex, we have talked about machine maintenance after breakdown. Let's say we have a machine which has been failed in a production line. What we want to do is we want to invoke an AI service by providing the error code or error description. Let's say the user has some error description, he will go to the user interface and he will enter the error code. And what does it does? It will go to the orchestrator, and the orchestrator will process this input and invoke an AI service which says, okay, find similar problems with this error code. It will find similar problems from where? From the knowledge base. As we said, we will collect all the relevant knowledge from these use case scenarios and populate in the knowledge base. So the knowledge base will have the collection of all the data like previous failure history or other details. So it will find the information. It will display to the user what is the correct resolution. So if the resolution is say we want a new part or we need some time to fix this machine, then what does this orchestrator do? This orchestrator can intelligently invoke another AI service, say to reallocate the machine so that the production line be reconfigured with a new machine, and we can continue the production environment we can run the production continuously without bothering about the failed machine. This way, the components come together in the high-level architecture to solve a particular use case or scenario. Then I would like to introduce about the key building blocks of our architecture. First of all, as we said, like our FAIRWork project goal is to make democratized decision making. So here we want to introduce the human aspect as well. So here we are using DAI-DSS intelligent sensor box. What does this does exactly is we will use some biosensors like a smartwatch or a biosensor shirt or eye tracking glasses, where the operator can use them, and we will track the vital parameters like his heart rate or temperature and etc. And then we also want to capture some of the working environment conditions like air quality and temperature and humidity in the area where the operator is working. what does we do with this data? We try to implement some intelligent solutions which can provide some key metrics like cognitive emotional stress of the operator, or a psychological strain or fatigue on working on a particular production environment or a machine. Based on this data, we can use this data and display it to the operator if we want to get his state, how his mental or fatigue, and then also we can anonymize this data and populate in the knowledge base, as it is important that these are the sensitive data of an individual. We want to make sure that it is anonymized and populate in the knowledge base, and various AI services can use this data to ensure proper allocation of worker to a machine. Let's say we have a scenario where we want to allocate workers to production lines, and based on this data we can see whether particular operator is comfortable in working on particular machine or not. It's not that we just eliminate that worker, but we will try to improve his comfortness in this allocation. Then we have DAI-DSS knowledge base. DAI-DSS knowledge base is the main central data repository in our architecture. It is the place where all we store the relevant data. As I said, we will collect all the relevant data for the use case scenarios and store it in the knowledge base. So mainly the knowledge base is implemented based upon our EDM True PLM, which is implemented based upon ISO 10343 open step standard. So this True PLM will offer a server application where you can create digital shadow representation of a physical entity, and also you can store both structured and unstructured data, which will become as a data lake. This data lake is implemented based upon EDM database, which is one of our backend product. Then what is ISO step standard? So ISO step standard is the standard for product data exchange. Initially, it was implemented in the late 90s for exchanging of CAD model data, like from one CAD simulation, one CAD software to other CAD software. Later, it has extended its functionality to include product lifecycle management data and logistic support data, and also like simulation data as well. So our data repository, the knowledge base, is implemented based upon this standard. So we focus on exchanging product information using this standard. So any project which has been integrated with the knowledge base can be exported as a step file format. So why we need standard implementation or a standardized data repository in implementation? Here you can see two recommendations from AI. One is from AI, where they exclusively mention that digital twins which are implemented on standards are easy to integrate or make them interoperable. Let us consider an example, like in today's situation, that digital twin implemented in one platform cannot be or need not to be easily integrated to other digital twin. It will require complex technologies or interfaces which we need to do. But if you follow standardized way of implementing a digital twin, then it is easy to integrate which other digital twin which is implemented in similar standards. Similarly, the European Commission is also recommending the use of standards in development of a project, so that this will help an interoperability as well, also provide a common understanding of a product. So we in Yotna is trying to make a standardized data repository in this project, which will help other components to access the data, also create digital twin and digital shadows. Now I would like to introduce you some functions of the DAI-DSS knowledge base. Here we have, as I said, we use a standardized data repository using ISO 10343 standard for data storage, and we provide a REST API integration or IoT integration for storing sensor data, and also we have a client application, and we can create digital twin and digital shadow representation. On the left of your slide, you can see the like a knowledge base client application, and next to that we have the API function documentation where different REST APIs can be used to access the information. Then we have this, as I told, we are using ISO 10343 standard repository. Here you can see we have a manufacturing sensor data here in a CSV file format, and what we have done, we have taken this file and imported it into our database using Express Data Manager, and the data is now standardized in step format. You can exchange this information using step format, and you can use any CAS step format compatible software to view this data. And here you can see some other standards which we have implemented in our Express Data Manager for data interoperability and data import and export. Furthermore, apart from data storage, the knowledge base can also necessarily help to create a digital twin. So I will just let you know like what are requirements to create or implement a successful digital twin. First, we need to have a physical product, like the ship which we have here is a physical product, and then we need to have a sensor package for collecting relevant parameters from the ship. Then we need to have a gateway or similar hardware which will collect the sensor data and process this data. And then we need to have an network for transmitting this data which is collected in the gateway. Then we need to have an IoT framework, let's say Arrowhead framework here. And then we need to have an CAD model or a PLM model which need to be stored in a data repository. Here our PLM will store this CAD information or PLM information which makes a digital representation of this physical asset. Then we have the sensors, and then we have these AI models which we are trying to implement. So once we have this digital representation of the physical asset and the sensor data, the AI models can use this sensor data and make some predictions, or it can give us some estimates which can be helpful for decision making scenarios. So here our knowledge base is able to host a digital shadow, and if we use some smart technology like AI, then it will become a digital twin. Now I would like to introduce you how we can create a digital shadow representation in our knowledge base. Let us consider we have a crane which is a CAD model in 3D, and we want to create a digital representation of this in our knowledge base. So what we can do is, one, we can take the step file of this one and we can directly import it to our knowledge base, and it will automatically create the product breakdown structure. It will create all the information that is required, like with its material properties and everything. And you have this digital representation in our knowledge base. Furthermore, what else you need to do is you need to identify the sensors which you need to associate with this product, and then create some breakdown properties in our knowledge base, and you can then use the REST APIs to push this data to this digital model. Here, hence you will have a digital shadow where you will have this continuous streaming of sensor data to the digital representation. So in other case, if you don't have a step file, I mean, in many cases you don't have a step file for a physical product. Like let's say if you want to show the human information, let's say you want to create a digital representation of this human. How can you do that? In our knowledge base, you can use reference data. Here I am just showing an example. On the left side of the screen, you can see a production environment where we have 2 production lines, where we have four machines and 4 operators. What you want to do is you want to represent them in our knowledge base. What you can do is, first you can take this machine properties. Let's say you want to create a digital representation which has the machine name, installation date, status, it's currently either it is working or it is in breakdown condition or is failed or some other reason. And you can create some properties like sensor data and which sensor data you want to populate. Similarly, you can create some information for an operator here, like his name, ID, and his status information. Once you have created these breakdown properties in our knowledge base, they can use your REST APIs to upload this information, and you can get live information about what operator is working on, what is the state of this machine. Furthermore, this data can be used by other components, or they can be exchanged using step format. This product breakdown structure can be automatically exported as a step file. Here is one more example where you have a product specification manual. Here we have a collaborative robot, and it has some product specifications like part number and weight control. It has some its specifications. Let's say in a scenario we have these 2 robot specifications, and we want to allocate one of the machine for certain task. But if the AI model need to access this, it is in PDF format, so it will be a difficult thing where every time you need to process this PDF file. So what we can do is we can create a digital representation of this product manual in our PLM using reference data. Here you can see, like, I have created the breakdown properties using product name, part number, weight, and control weight. You have this information now digitally available in the system. And now if an AI service or model need to access this information, it can use an API endpoint. Here you can see the HTTPS request of an API endpoint, and you will get an output in the JSON format. Here you can now get the properties of this robot, and if you want to compare and see which robot is better suitable for your task, you can compare with this information using this API response. Then we have the further important crucial component in our architecture is DAI-DSS configurator. The configurator has 2 parts. One is configuration framework, and the other is integration framework. The configuration framework is used for creating decision models, and this model data serves as an input for the integration framework. So here we have the integration framework where we have GUI configurator. This GUI configurator is used for creating some user interface layouts, and you can decide which key values or sensor values you want to display. So this GUI configurator acts as an user interface builder. Then we have this service configurator. The service configurator, what it does, it will map key data sources from the knowledge base to the AI models, AI services. And then we have this deployment configurator. As we said, like earlier, we have a GUI configurator, which will configure the user layout. Then the deployment configurator takes this information and it can be deployed on an as a web page in a mobile or in a system or MS Teams apps. Then we have the user interface. This is the place where user can interact with our framework. The user interface has multiple purposes. On the bottom right of your screen, you can see an web page where we have this user interface. Here, the user interface is not only displaying some key metrics like sensor data, like you can see some bar graphs and some line graphs. It is showing some key metrics, but also you can invoke some AI services. Here you can see access service, few rows of access services. Here we have configured few AI services, and the user can interact with this AI service. If you want to invoke some AI service, you can go here and interact with this interface and invoke that service, and you will get some decision output from this and displayed on the interface. Then the other crucial component in our system is the orchestrator. The orchestrator is the critical component which executes the overall decision support system, and it manages and configures the required services and workflows that are required. It is ensure it's like a working engine which will take input from the user interface, and it will process the request. Let's say we have an AI request, AI service request from the user interface. The orchestrator take this and invoke the required service from the AI enrichment module. Or if the user interface need to visualize some sensor data, then the orchestrator will just use the data access service and just pull the data from the knowledge base and display that key values. Then we have this final DAI-DSS instrument. As we said, we want to use AI as a decision support for the user. So here we will have the AI enrichment will have a list of AI services which we have implemented. Here you can see the traditional machine learning service catalog, then symbolic AI service catalog, and then agent-based services. So what does this AI enrichment will have? It will take the knowledge. It will take the data from the knowledge base and train the machine learning models, and it will store this information in this enrichment, where each AI model will have an REST API endpoint, and the other user interface or the configurator can configure this API endpoint and invoke the particular service. Here I would like to present you about an example of an implemented a sample API AI service. Here you have an use case scenario for Flex, which is to build an automated test building. And what we would like to do is we want to get some outputs of efficient safety of certain design criteria, like layout. Like here in safety, we have certain layout, and then the robot has certain movements, and we have selected particular gripper for the robot, and we have some other details for the safety, and as well as the needed cycle time and traffic around that robot, and then operator skill level. So this will be input for the AI model, and then what does this image here API interface shows. Here we have an AI model which is trained for this using this fuzzy logic for an efficiency and safety assessment, and we can use an Flask app in Python or Python to create an API endpoint, and it will take this input parameters and give us an output, let's say efficiency as 6.80 and safety. So this is one of the example we can show how the AI model can take the inputs from an user interface and give us a required output. Furthermore, here I am just showing an same example with a GUI. Here necessarily this is a local implemented GUI, but what we can achieve is in our user interface we can have similar layout where the user can play with the input parameters, and he can get the efficient safety as an output as displayed it here. Thank you, and now it's time for taking some questions. If anyone has any questions, please raise your hand or let me know. If not, then thank you very much for being in this webinar, and we would like to be in touch with you. And these are the contact details where you can contact us and get more information about the FAIRWork project, and we would like to collaborate you with further to discuss this FAIRWork project idea. And yes, thank you.